The third type of elimination problem involves using scalars a little bit more aggressively. And so, Luke, as we're going to use scalars a little more aggressively, you're going to have to look at your two equations and say, what is going to be the best thing to try to drop out? So here I'm looking, I have 2x and 6x. I have negative 5y and 20y. Neither of them lends itself, Kyle, just to adding vertically and dropping something out. But can you think of some kind of a multiplier that would drop out the y's? What would I have to multiply one of the two equations by to drop out the y's? Zach? Okay, you said 4 or negative 4? All right, let's think about it. If you multiply the top by negative 4, you're going to get positive 20, right? So let's just multiply by positive 4. That's a good call. So here we're going to write down the first equation. 4 times 2x is 8x. 4 times negative 5 is negative 20. And 4 times negative 19 is negative 76. The second equation doesn't change at all. 118. If you don't have your calculators, we may be needing them in a second because it looks like our numbers are getting big. With Zach multiplying the first equation by positive 4, he got opposites, positive 20 and negative 20. Now the problem is very, very simple. Haley, can you add these up for me?
Yeah, 8 plus 6 is 14x. And then that would equal...
8 minus 6 is a 2. I think 42. Can someone check me?
What?
Yeah.
118 minus 76 is 42. All right. Thank you, Haley. Divide 42 by 14. X equals 3. What's the chance it's going to be so nice and neat? On your homework, pretty good. In real life, not so good. But that's okay. All right, you're going to have to choose here. Let's go out on a limb. Let's not use the first equation to solve it, okay? Just for the sake of being different. 6x plus 20y equals 118. 6 times 3 plus 20y equals 118. 18 plus 20y equals 118. Subtract 18. Oh, this is convenient. 20y equals 100. That's a nice, simple solution. Divide by 20. Y equals 5. The fact that we got a nice, perfect answer, Justin, is paramount to saying very likely we're correct. But we still need to check it. In this case, I used the second equation to solve it. So, John, I'm going to use the first equation to check it. So here we go. Here's my first equation. 2x minus 5y equals negative 19. Let's plug in our numbers. 2 times 3 minus 5 times 5 supposedly equals negative 19. 6 minus 25. Is that negative 19? It is. So my answer is 3, 5. I wanted to show you that because that is a very involved scalar. Much more involved than the others because you're multiplying by a large number, you're getting big stuff. But once again, the goal is just to get a positive 20 and a negative 20. Now before we flip to the last one, I want you to think with me. Isolate in on the 2x and the 6x. Zach gave us a good multiplier there. Is there anything you could have multiplied by to drop out the x's instead? Let's stay away from thirds. If you multiply by 3, you get positive 6x and positive 6x. How about negative 3? Negative 3 would give you negative 6x and positive 6x. So you could have dropped out the x's. It doesn't matter. Whichever one looks more convenient, which looks easier to you. So, let's look at our last one here, number 6. All right, Zach and Josh have done a nice job for us so far. Someone else, help me. What do you want to drop out, the x's or the y's? I hear x, okay? So I have 24 and 6. How am I going to get this to work? Jalon? Excellent. Multiply the bottom one by -4, because that gives you that -24. So let's recopy the top equation exactly. Jalon, can you multiply that bottom equation by -4 for me? -24x. Good. Nice pickup on the positive, because a negative times a negative is a positive. Thank you. 144. All right. Jalon did a nice job of pulling out. Do you remember what that -4 is called? Scalar. Yeah, it's the scalar. All right. So we add these up vertically. All right. Ryan, do you feel comfortable doing that? Add them up vertically for me. No x is good. 14y. Good, you're faster than I am. All right. And I know that 14 times 14 is 196. So I'm going to divide by 14. And that's my first value. Now, which of the two equations at the top looks easier to work with? The 24x or the 6x? The 6x. So Kyle, let's use the 6x. Here we go. I'm going to write it down. 6x minus 3y equals -36. 6x minus 3 times 14 equals -36. 3 times 14 is 42. Am I going too fast? Slow down a little bit, sorry. I'm going to add 42. So 6x equals 6. That's way too conveniently nice. X equals 1. Once again, Haley, the fact that we got such a perfect answer at the end is paramount to saying, oh, I'm sure we're right, but let's make sure. I used equation 2 per Kyle to solve it, so what must I use to check it? Equation 1. Here we go. 6 times 1 minus 3 times 14 is supposed to equal -36. 6 minus 42, is that equal to -36?
That's the second equation.
Use the same equation twice.
Yeah.
I did. You're right. Yeah. That wasn't intentional either. I'm sorry. All right. Let's. No, you can't, because of course it's going to work. It's just where we started. Abby's favorite color is pink. No matter how many times I ask her, it's still pink. So let's use the other equation. Thank you for catching me on that. That was not intentional. 24x plus 2y equals 52. 24 times 1, 2 times 14 equals 52. 24 plus 28 equals 52. Yes, that does work. Okay. So 1 comma 14. Thanks for the catch there. Will this work down here? Of course it will. It has to, because we just did it here. So my big screw up there, my fault. All right. Question.